Hello once again. This video describes the use of multi-layer perceptron neural networks for function approximation. This video is made as a part of assignment 4 of nature-inspired computing course at IIT Gandhinagar. The functions which we will attempt to approximate are Booth function, Stiblinsky-Tank function and Egg-Holder function. All these functions map from a 2D space to a 1D space. The corresponding surfaces formed by these functions are shown next to them. We observe Booth function has only one turning point while Egg-Holder function has countably many. We'll see this makes approximating Egg-Holder function the most difficult. Now coming to the neural network structure. We have two inputs to our network. The inputs are fed to a hidden layer with n number of perceptrons. This is the only hidden layer in this network. The output of this hidden layer is fed to the final output layer. Since the function this neural network will approximate has a 1D output, the output layer has only one perceptron. The number of perceptrons in the hidden layer may be decided by constraining the degree of freedom for the equations. Each data point gives an equation that the weights and biases will satisfy for zero error. Here, the unknown are weights and biases in the network. To keep the degree of freedom close to zero, we have number of unknown equals number of equations to be satisfied. For learning, we have implemented the variable learning rate backpropagation method. The algorithm involves slowing down the learning rate near positions with very steep descent and increasing the same where the gradient is very small. On the screen, we have the parameters used for the VLBP learning. For training the neural network to approximate the Booth function, we have used quadratic activation function for the hidden layer and linear activation function in the final layer. On the right are 40 points taken from the domain of Booth function which were used to calculate the mean square error to test the accuracy of the trained model. In this frame, we'll see the network model under training. To the top right, the window shows the contour map of the target function, the Booth function in this case. Below that, we have the contour map predicted by the neural network for the target function. To the left, we can see the neural network evolving over iterations. The brightness of the edges is a visual measure of the magnitude of the weights for the corresponding perceptron. Now training the model, we can see the neural network gradually perfectly replicates the Booth function. Moving on to the Stiblinsky-Tank function, we have used a biquadratic activation function for the hidden layer and a linear activation function for the final layer. Again, the points for calculating the mean square error can be found in the table to the right. Starting the training for this network model, we observe though the model does not exactly replicate the target function, but it roughly imitates the function by having low values in the middle and high values close to the edges. Finally, for the Egg-Holder function, we have used the tan sigmoid activation function in the hidden layer and a linear activation function in the output layer. The test points where mean square error is calculated is again given in the table to the right. Running the VLBP algorithm to train the model, we observe the approximation to the function does not even vaguely match the target function contour map. In fact, after a large number of training iterations, the error seems to oscillate and not reduce drastically anymore. Just to benchmark our code, which was written from scratch, we compared the performance with the standard Keras library by TensorFlow. Apparently, the Keras model uses some technique to smoothen the steep gradients. However, the result of the Keras model is equivalently disappointing as our code. We also built an RBF network to compare the performance. Though the model from the RBF network does better on the mean square error metric, the overall contour map on the right does not at all resemble that of the target function on the left. Thanks everyone, stay safe and have a nice day.